This is a short discussion about cloud computing. For today, no, this is a short topic, no, maybe an hour or so. Got intro to cloud computing, security, no, in cloud computing, some challenges, benefits, so and trends, no. And then we summarize this with the key learning points, no, and I'll be disclosing some of my references on this Asia Open Run course. So when we think of cloud computing, no, was it what is really so yeah, we are always now hearing a lot of tech buzzwords like data science, cloud computing, blockchain, no? So trying to a bit demystify what really cloud computing is. Long story short, no, we've been using cloud computing for quite some time, and used to be we just call it data centers, no? And we got co-location, co-hosting, but we made it a general terminology, not especially for a lot of these types of hosting, no? Make the term generic, no? Cloud computing. Okay. So again, in the early days, no, we have a centralized computer, no, it's isolated. These are the big boxes, no, that could fit a room. That everyone would be scheduling access on that computers, no. Eventually, no, we had it made, no, na we have terminals that could access those centralized, no, heavy duty computing resource, which to some degree it became a bit broken apart yung access, no. And then we started, no, in the 1980s to the 90s, no, the era of personal computing, where this has been technically decentralized, no. So you have your own computer, you have your own applications running on it, and network was booming at that time, especially mid 90s to late 90s, no, when internet was becoming mainstream. And the progression after that would be cloud computing, where we realize that having your data on a single computer makes it a challenge, no, to share relevant and up-to-date data across all other people in the enterprise and our consumers, no? So we had the idea that, okay, if we put it centrally again, as if it's in the 1960s and 70s again, we could have everyone access it a bit, how do you call this? You would have shared access to those types of resource, no? So, and that also has, no, some of the challenges too. And there's actually another step here where we are deploying, no, edge computing, which is my topic the next week, no? So from centralized, we're now trying to again decentralize some of those components back, no, to solve some challenges on cloud computing. Okay. So for our players, no, yeah, in cloud computing, we had here a June 2022 Gartner Magic Quadrant, no, and of course our leader here would be AWS, Microsoft, and Google. And luckily, no, we have one of our speakers here later, no. Well, they've been into cloud computing since one of the early adopters, no, especially these three organizations, no, where Amazon has AWS, Microsoft has Azure, and Google has GCP, no? And Microsoft made that move, well, since they practically own, no, a lot of operating system that's being used in the enterprise today. So it does make sense for them to host these cloud computing services like Active Directory, storage, and email too, no? Where email, Google had one of the first software as a service email system, no? Gmail, no? That was very successful. And now Microsoft is catching up at least on that part. For the others, no, we have Alibaba, Oracle, Tencent, IBM, and Huawei Cloud, no? Trying to get to the leaders quadrant too, no? But so far, we have these three, no, major players in cloud computing, no? And in terms of relative market share, no, so this is 2022 stat, no, we still have AWS leading, no, with 34% market share, followed by Azure, again, which makes sense because again, Microsoft owns a lot of the operating system in the enterprise. And then thirdly, we have Google Cloud, no, and Alibaba making the push, having 5% with IBM, Salesforce, Tencent, Oracle following suite. So, well, ultimately with this stat, no, it's still AWS. That's the number one vendor for cloud computing. So for our cloud computing service model, no? So we have a few, no? There's actually a lot of sub computing service model, no? But these are the three main. We had infrastructure as a service, where you practically are given, no, your infrastructure based on your design, based on your specs, no, and you would have to manage them. No, it's just basically a server provided to you. Okay, and you have to configure it, you have to patch it, you have to load your programs and softwares on it. This made it a bit easier, no, for any organization to deploy resources. No? But remember that before cloud computing, you have to plan out your capacity, made out the specs, no, and have asked for a budget for it, no, and then now have a bid, no, with different various, no, hardware vendors on who would be able to provide the best value for money, and then once you selected a winning bidder, you would need maybe 30 to 60 days for them to deliver the hardware, and then upon delivery, now you'll have to configure them, no? And that actually was a problem, no? For anyone here, no, who is managing an infrastructure during the pandemic. No? So especially in the early days of the pandemic, 2000, yeah, 2021, where when you order something, no, they would have a lead time of 60, no, that's 180 days to a year, no, before they could deliver it. And if you need to expand, no, something goes wrong, your hardware goes down, no, you need your infrastructure running, no, as soon as possible. No? You cannot just buy a hardware, even if you have the money to buy them. No? You cannot get hardware. It would take time for them to deliver because, well, all the manufacturing plants are running at a skeletal force because of the pandemic. So that there was a boom in adoption of cloud computing because, well, if your hardware would arrive, no, in a year's time, if you have a credit card, then it's approved, of course, by management. No? You could just put up your infrastructure in as little as 15 minutes, including the sign up. No? So that actually made a boom, no, in cloud computing. But that's not without a problem, no? Because a lot of the traditional infrastructure engineers, no, have this outdated mentality. Now you could just create and ship, no, your system and deploy it in the cloud, and it's gonna work. It is working, no, but that's not the very efficient use of cloud computing platform too, and it's not that secure. We'll see that in a bit. We also have platform as a service. This is where sample here would be GitHub, Docker, Kubernetes, now where you are provided now with some of these components already managed by the cloud, but this typically would have something to do with your developing toolkits and pipeline, no? Like continuous integration and continuous deployment, no? Where you could upload your code and then from your repository, a system would get that code, try to compile it, look for any warnings or errors that might yield the build unusable, or if it's usable, no, they could even pass to other tests, no, like unit testings, performance tests, and security tests. So, and then ultimately at the end, you'll be given a go signal or a green light if it passes all these tests, and then now you could decide, no, if you could just deploy this on maybe your infrastructure as a service or SaaS system. Speaking of SaaS, again, we could maybe equate this to Microsoft 365 or Gmail or G Suite, no? Where you are not managing any hardware or platform, you are just given an account, no? And you could create multiple accounts, no, for your organization. And yeah, as the name implies, it's software as a service. Yeah, you are demystified, no, from the hardware component on how this stuff would actually operate. No? You are given an account, the system on the back end, the hardware, the availability, it's now being taken care of the vendors, no? For you. Next, we have types of cloud computing deployment. Private cloud, no? This is where most organizations started, no? Where you have your own data center. You have your servers hosted there, and then eventually, no, we had virtualizations, no, to the solutions like Citrix, Xen hypervisors, VMware, no, where we host our own cloud computing infrastructure, and we are provisioning VMs there, even as early as early 2000s. I've seen organizations try to deploy clusters, no, of cloud computing, and then there's also the entry, no, of open source virtualization platforms like Xen, no, and AVM that enable this, and eventually we have a good cloud computing on-prem platform like OpenStack. But it's still limited, no? The thing with that is you would need to manage the hardware part, no? And not only that, no, hardware part also includes power, cooling, and internet bandwidth. No? So those are stuff that you'd have to manage if you're running your own private cloud. Hence, other organizations that wanted to do away with that kind of responsibility, they are starting to adopt public cloud. No? But do note, there is a shared responsibility model which we'll discuss in cloud computing security. That not everything. If you go to public cloud, not everything is taken care of by the provider. And there are still a lot of organizations that cannot fully deploy to public cloud, especially us here in the Philippines. We have some issues with data sovereignty. Our, let's say, the banking sector would want to keep a lot of their critical personal records on-prem. But there's still BSP starting to lose up on you being able to use public cloud, but some data would still be retained locally. Hence, there is a huge adoption here on hybrid cloud for traditional organizations. For a lot of fintechs, of course, they would most likely be cloud first and deploy to public cloud. But most enterprise that has been existing for quite some time, they are running on hybrid cloud where it's a mix. You still have workload on-prem, but most of your workload now is being shifted to the public cloud solutions. This is most of us would be on the hybrid cloud deployment model. Okay. So, moving on, you use cloud computing, so it must be secure. Again, that's not necessarily the case. The first is, well, for public cloud, they would want to delineate what the vendors would be taking care of and what is the responsibility of the customers. So, we got this trend, or way of thinking that if we deploy to the cloud, it's going to be secure. That's not the case for the most part because, well, cloud is just someone else's computer now you're using to deploy. And if it's as raw as infrastructure as a service, then you take care of the firewall, you take care of the patching, you take care of your software security, your development lifecycle. That is on you. And the client data, as you can see here, it's actually your responsibility. So why would you blame, let's say, AWS if your system gets breached? If you allow SSH to come in on all the internet IP address, and you have a root password with password, of course, that's going to be easily brute forceable. There's a lot of attack bots that attempts those basic credentials. So, I mean, that's on the deployment team. Why did you allow that? Don't you have policies or security in place to prevent that kind of a basic logon? And I do a lot of incident response, including the cloud, and it could be as simple as one of the users got phished with their credentials, and then the threat actor trying to reuse that credential to log into the email system or log into the VPN, and now they are part of your infrastructure. So again, it's hard to blame the vendor for that, since it's your user who gave out the credentials and then now was able to compromise the entire infrastructure. So that has happened. That has happened a lot. So we need to be aware. At what point is the vendor going to be responsible? And on here, it's the software for management of this compute, storage, database, and networks. And also the hardware. In case there's any hardware failure, they would be the one replacing it transparent to you. But again, if it's infrastructure as a service, you are responsible for patching the OS, configuring the OS, configuring the accounts, and ensuring that your environment was encrypted and protected too. So, okay. So this is from AWS shared responsibility model. There's also one in Azure that actually delineates SaaS, PaaS, and IaaS where what components are under the responsibility of the vendor or under the shared responsibility of the customer and the vendor. Okay? And not to scare, but basically they're just saying that if it's on-prem, everything is your responsibility here. But even as you move to the left, software as a service, responsibility would still be, especially for information, devices, and accounts and identities, no? It's gonna be under the responsibility of the customer, not the vendor. Okay? So when someone says cloud is secure, yes, depends on how you make it. You would still be responsible for most of it. Okay. So to augment, no, that issue of cloud security, there is an organization, a Cloud Security Alliance, who are releasing and updating what we call the Cloud Control Matrix. No? So they recently released a version 4. So this is a bit recent, no, than the older one was CCM version 3. No? But this is what we're using now, no, to determine if our cloud deployment, no, is secure. So we could use this to validate, no, control framework for cloud computing, and it basically split, no, um, different roles and aspects of technology to 17 domains, no. And each of these domain, no, has been broken up into 197 control objectives. So that's a lot of items that you need to evaluate for a cloud deployment, no. But it's good, no, because now you don't have to guess, no, what do you need to check, what do you need to configure. Now everything is aligned that you could have a checklist, and you could even say, no, this does not apply to us, so move on to the next. But now you have a list, no, and a guideline on how to do secure deployment in cloud, and which actor, no, within the cloud supply chain would be responsible for that item. So this 17 domains, no, it's a lot actually, from audit and assurance to application and interface security, to even to business continuity management and operations, and a lot more. So this again, these are 17 domains. It's split into 197 controls across all of this. So you could start checking. And unfortunately, no, we don't have much time, but I could talk on for days, no, for each and every one of these controls, no. um, which is very interesting too. There's a lot of this aren't considered by a lot of infrastructures engineers, no, when until they saw that okay, so this is part of our responsibility, so we have to have a solution or a control for this. So they, for lack of better term, no, it makes everyone aware, no, on what they need to be able to check and configure. And you could actually use this to evaluate cloud vendors too. Of course, most of the Gartner leader in Magic Quadrant would have a configuration or an item na you could configure this, no, because they are part of the Cloud Security Alliance, where you could have some of these tweaks, no, to be able to implement controls on here. And if it's a new vendor, now you could ask them, are you compliant to CCM version 4, and do you have a way, no, for infrastructure engineers to be able to configure that, no, if needed. And if they don't support most of this, then of course you could now make your evaluation that yeah, that's going to be a risky for us, no? So you might want to go to known vendors for this, no? Speaking of this, no, there is a link here at the bottom from NCC Group, where you could have, no, a spreadsheet of a checklist, no, for Cloud Control Matrix version 4, where well, you have a spreadsheet. In case you have a cloud deployment, you could use that as your template for monitoring this activity. So, okay. And it's free, so you could use this for free. Now for the Ayora course, no, so we wanted to have our students get their feet wet, no, in cloud computing. And so in case you haven't noticed, no, most major cloud vendors provide free instances, no, for you to get your feet wet. So you could have free instance from GCP, AWS, and Azure. Of course, it's not going to be the big boxes. No? It's mini Linux box where you could log in, maybe host your basic WordPress site. No? Well, maybe a 500 meg storage or stuff like that. But it's the micro instances. No? But it's a full Linux instance running. Maybe for Azure, no, you have a mini Windows instance running. No? You could play around with to be able to figure out the UIs, the interfaces, the configuration aspects of it. But at least for me, what I would want to impart to you is be familiar with command line interface, where you could access various features via APIs. The thing with cloud vendors is they are in the forefront of technology, and they are developing a lot of these techs. And um, it's not unlikely, that your interface today would be different from your interface by next week. No? So sometimes the button you are accustomed to is on the, let's say, lower left side. But by next week, when they deployed something, they made it deprioritized and put it somewhere 3 levels deep. No? You will be having a hard time figuring out where it is. But if you control your infrastructure via API and command line, it's going to be there on the command prompt. So you could start your deployment and script it out programmatically on what have and you don't have to take care of finding where's that button to deploy this cloud instance, something like that. So use CLI, be familiar with it, and they have most, especially the major vendors, they would have a lot of free learning materials because, of course, they would want users not to be familiar with their platform. So take a look at their offering for AWS, GCP, and Azure. And you could get certifications too from them. Of course, a lot of their mainstream ones will most likely have some cost involved, but they have a lot of free materials on for you to learn. And again, well, it's 2024, so you need to be able to be familiar and at ease in using cloud computing. If you see a sysad or a network guy, when you say cloud, they become very adverse against it. No? So that's not going to be helpful on their careers. No? So it's everyone. If not fully moving, they would have a huge component of their workload in the cloud. And if you have an engineer that doesn't want to touch the cloud, I'm sorry to tell, you'll be outdated pretty soon. Okay. So for our activity, we want to at least for our class in Ayora, we want them to set up a free AWS tier. They would need an email and a credit or debit card, unfortunately, but this is how they would validate if you're really a person. Because without that, anyone could just subscribe to a lot of free instances and use up a lot of the vendor's resource too. So if you are in the classroom or university setting, you could talk to AWS for education. They would be able to help you out, maybe figure out what course could be offered to your university. And again, they are very receptive on this because they want, of course, students to be familiar with the platform so that when they go to the industry and after graduation, top of their mind would be the platform that they are using. So this is also a part of their marketing. So next is cloud computing. It's not without challenge. So we have here at least top five challenges that we will be discussing: security, compliance, vendor login, data migration, and bandwidth. So as mentioned, when you deploy to the cloud, it's not necessarily secure because, well, at the very basic sense, the identity is still under the responsibility of the customer. So here, one of AWS clients, CodeSpace, supposedly with proven backup plan, was compromised, and the threat actor was able to gain their root account in AWS, and eventually one of the early ransomware organization that they encrypted, changed the accounts, and said that if you don't pay, we'll delete all your data. And they were attempting to restore their information, and the threat actor got a hold of it because they're practically monitoring the infrastructure, and they just deleted everything, even with their proven backup plan, because their backup was also in the cloud. And someone gaining access to that root account basically have a full control. And well, this is almost a decade old, 2014. This is 2024 now. Since then, AWS has put up a lot of controls on the root account, and they even state that you should never use this unless it's an emergency. It's a breakless account. So you need to have sub accounts that would have different permissions and roles, no? That in case it gets compromised, it's gonna get compartmentalized. So you cannot do this type of attack anymore, no? But I'm still seeing early new infrastructure guys, no, using the root account to deploy various instances, and which is not a best practice. Again, you could now tie this back to Cloud Control Matrix, and you'll have some control on the admin accounts, no, and the accounts, no, to be able to minimize of this instance from happening again. Okay. Again, yeah, if you're fully in the cloud, no, and you even have backup, but it's also in the cloud, no, you might want to think, no, should we have a backup on-prem now, which is counterintuitive because everyone would now want to push everything, including backup, to the cloud. But with instances like this, no, you might think twice, no, of putting everything in one basket, something like that. And you could say, well, that's a decade old, no. So, if you have a son or a kid back then, it's already what, grade 5 or grade 6, 10-year old. So what's new? I don't think that would happen again. Well, there is an incident recently. This was, if I'm not mistaken, May, this year, where Google Cloud accidentally deleted, an Australian pension fund, UniSuper, which is worth $125 billion, wiped out. Infrastructure was wiped out, for some accident, and Google tried to help them restore their service, no, but UniSuper, at least, no, they had a backup account with another cloud provider, which enabled them to restore. Now, if they did not have that backup account from another cloud provider, and everything's in the cloud, no, this is very catastrophic for them. So now you could be thinking na, okay, so if I have a GCP account, maybe I would have my backup in Azure or AWS, no? Or on-prem. But yeah, this has been there are instances of that happening, and you don't want to be the use case, no, of what not to do. And speaking of our government naman, we have our DICT having a cloud first policy, no, for deployment that they are advocating, no? But it does not, the cloud first policy does not necessarily mean go to public vendors, no? So fortunately, DICT have their own cloud instance on-prem, and they also are subscribed to I think they're using AWS right now, no, for most of their workload. So it could be either or. Where they are recommending, of course, no, not to host your own infrastructure, no, but have them be deployed, no, either to the ICT cloud or to the ICT cloud taking care of the vendor like AWS. And with this policy, no, of course, AWS would want to comply to various regulations, no, for the Philippines, like for Philippines, a lot of the financial institution, which is one of the early adopters of cloud, no, would need to comply with Bangko Sentral, no, and we have BSP 982 circular 982 that AWS says that in Philippines context and privacy consideration, no, they are compliant to BSP 982. And for other various compliance program, no, of course, well, the AWS again complies to CSA. And you could have all those 197 controls from CCM version 4 not to be able to pick with AWS. They also are, of course, certified with various ISO 9001, 27001, 27017, and the rest. No? And also compliant to GDPR if you have data from European clients, PCI DSS level 1, and SOC compliance too. So anyone asks now, right, why would I go to vendor A or vendor B? Well, if they are already compliant across multiple regulations, no? So that's a good indicator that they are constantly being audited, they are monitored, and you have some sort of assurance, no, that they have this process, no, to help you out. The thing is, even if they have this certifications, no, and compliance, if your user was phished and gave out their username and password and OTP, then none of this is gonna matter. They're gonna get you're gonna get compromised anyway. So it also is, no, again, on that component, the identity and access management, it's gonna be up to the customer, no, to be able to have their users aware of common attacks, what not to do, and put in some other security or additional controls. So like, let's say your root account, maybe you could put restrictions na you could only log in via the corporate network, no? So even if a threat actor got the username and the password and the OTP, but they are from the internet, no? They will not be able to log in to the dashboard, no? So which is an additional control. Um, but it could also happen that the threat actor is already in the organization, and of course they could use your infrastructure to log in. So that's not a foolproof way, but it adds additional barrier, no, to entry for various threat actors. Okay. So next issue would be vendor lock-in. Now, of course, all vendors would want to keep their customers and use various products uh, from their solutions. No? So this is common, no, for everyone. So the problem now would be if you want to migrate out, no, to, let's say, you are in Linode and you want to migrate to Amazon Web Service, it's not going to be an easy path. No? So chances are you need to get your database and your code, no, and redeploy it via other means. No? But that also makes it uh, the customers, no, locked into these vendors. And well, aside from that, no, your command line interface, your UI, your familiarity with the dashboards and command line would also play a factor, especially if, let's say, most of your infrastructure analysts and engineers are trained for AWS. uh, they would of course hesitate to move to GCP or Azure or Linode or anyone for that matter, because now they have to study it again. And uh, especially for AWS that has a lot of features, no? A lot of the other cloud vendors would have a hard time following suit. No? That most likely they won't have specific features that you are very accustomed in using in the AWS, but they don't have it in maybe Linode or Vultr. So this is a problem, but it's a challenge, but it has to be recognized early on. So if you are working with GCP, Azure, and AWS, typically your team, no, needs to have specialists or at least cross-train across those platforms, no, to be able to move around across this vendor and not to be locked in on one vendor only. No? And what would happen is even if it's very expensive, no, you don't have a choice because your engineers are uh, uh, only aware and skilled enough to be able to use on a single vendor platform. So either now you have to hire or again train them to other vendors, no, to be able to make a best cost and cost effective um, uh, investment across these services. Another challenge for cloud is data migration, where again we discussed this briefly a while ago. No, now you cannot just create and ship, no, your systems, no, to the cloud and hope that it works without any issues. No, so for the most part, it would work because it's basically just a code, and you have the OS in the cloud. You're gonna run it, no, but you might encounter some challenge like data security. So example, if you have an old software, no, that you're still running maybe on Windows 7, God forbid it's still running on Windows XP. No, most cloud provider will not support that OS. No, so even if you move it to the cloud, no, the old API calls might not work on your operating system, so you might not have an issue. And if let's say XP, no, for some reason it has to run on Windows XP, and for some reason the cloud vendor has that, no, are you going to be able to sleep at night that you have a Windows XP that you might expose to the public internet running your applications? No? So chances are not. No? So you need to be able to think of that. And also, data security. No? If you don't trust your cloud, no, for some of your data, and let's say you have a backup solution to the cloud, no, chances are you might want to encrypt that data before sending it out to the cloud and having it stored there. Now, I've seen this happen a couple of times where when the customer is trying to restore the backup from the cloud, only to realize that they lost the decryption key. from that backup. So they've been using this backup to the cloud for 3 years, unaware that they have the public key, but they misplaced the private key since way back. So they could encrypt it, but they could not decrypt it back. And that's a bad time to be in the backup team. And speaking of data transfers, especially for backups, so data volume is um, expensive. Not only in backup solutions, also migration. If you have a few terabytes of data, especially with the bandwidth of the Philippines, which is very expensive, and we have some a bit of a latency, because there's most of the cloud providers are out of the country, so you'll have to pass through submarine cables, which even though they are on the speed of light, operating on the speed of light, you cannot beat physics. There would be latency. So shifting out terabytes, even petabytes of data might be complex. Some vendors made through with the joke, na never underestimate the bandwidth of a van with a full of hard drives. That's a huge bandwidth. So AWS and other vendors would have that solution where you could ship them your hard drive, and they would load it to their data center and then copy the data over. So sometimes that's a very cost efficient and faster, faster way to send a large volume of data to the cloud. But typically, of course, you would have that encrypted, because in case that this gets lost, or was corrupted, or was stolen, you don't want anyone to just be able to read the data. So typically, it's an encrypted blob. They would load it, and then you would decrypt it once it's there, once it's loaded in the cloud. Okay. There's also issues and challenges with integration with existing system. So if you have systems that is on-prem, how would the cloud be able to interact with it? So typically, you would have a VPN connection to the cloud instances, and the cloud instances would now be able to come down to your on-prem infrastructure and do their thing, interfacing with them. And problem now would be, of course, what if the VPN goes down or the connectivity goes down? So if this is a time-critical application, chances are you will not risk having that control system in the cloud. You would still have to operate it locally. So typically, you would see this on utilities that operates on SCADA and ICS technologies. So while they might have a central dashboard for telemetry in the cloud, most of the decision making would be still on-prem, because again, you are trying to mitigate the instance where there is an internet outage and you don't want your OT environment to run without any control from the server. So typically, you would still have an on-prem instance for that. Another is cost. I've seen this a couple of times where they would just cost out how much would an instance be for a year's of worth of operation, and they would say now it's cheaper than buying the server and maintaining the power, the cooling, and the internet and the space on-prem. But they did not consider that sending and receiving large volume of data to the cloud might have a cost. And I've seen this on one instance where a local financial institution migrated everything to the cloud using that basic formula of the instance cost only. And what they fail to realize now, all of their 10,000 employees need to access those data in the cloud. Their bandwidth wasn't huge enough to be able to handle that. So now they have to increase their bandwidth. And that's the only time also that they realize that data being downloaded from the cloud has cost. So it turns out they missed that part. It's not by much, but the justification that they use that they would be saving a huge amount of cost if they migrate to the cloud isn't really that much, when all the factors were considered. So yeah, again, data migration, it's a very complex process. It requires you and your engineers and your business units to be careful on the planning and execution, and really identify all these issues beforehand, because once you have migrated to the cloud, it's going to be very hard for you to justify if you made a mistake to move back in. Most of us would double down once we have done the migration part. So Yeah. And well, tying up with migration is the bandwidth, no? Where if you could see here, no, Philippines has been a bit more on the expensive side of the bandwidth, unfortunately. This is well because we have before, no, we have the duopoly of two telcos. Now we have at least some other players trying to get into this business, no, that uh had effect, no, the pricing, no, that's going to be converged. And well, Starlink too, no, is also in the Philippines already, no? So they have been able to give connectivity and bandwidth to the masses at an affordable rate. Um, but let's say for Starlink now here, you it's a bit expensive now, around 2,700 pesos a month for maybe a 300 Mbps bandwidth on a good clear skies, no? But I do have it here at home. I'm averaging maybe 150 to 200 Mbps, which is not bad for satellite connectivity, no? But there is latency, no? So it's hard to do online gamings, no? I mean, it still works, no? But sometimes, especially if cloudy, you might get some lag a bit, no? But for day-to-day office use, no, it is usable. It's it has high bandwidth, and it does basically the main selling factor for that type of ISP is they're able to reach, no, various clients that telcos are not able to lay out a fiber to, or even microwave solutions, no? So now you have just one equipment that you have to buy, and now subscribe to 2,700 pesos monthly for I would say a high bandwidth link, no? But again, you need uh you need to spend for that. And 2,700 monthly for per let's say branch office that is not reachable via telcos high capacity fiber, no, would add up, no, especially if you have a lot of those. So still we are on the most one of the most expensive countries in the region that speaking of internet bandwidth cost. Okay. So next would be benefits, no, of cloud computing. Now, again, we have futuristic use cases here where with 5G, no, and high capacity links, no, that's mobile. We now have some use cases of autonomous vehicles, which typically would need hybrid ecosystem now, where you have still, of course, processing on-prem, no, because last thing you want would be your car asking the cloud if they should speed up or turn or hit the brake, no? If there's an obstruction there, now what if there is a loss of connectivity? So most of this real-time processing would have to be performed on-prem in the car, let's say for autonomous vehicles, no? And that's what we call edge computing, which we'll be discussing next week, no? Same time next week, not to preempt those discussions there. So, good. A lot of this data that is being generated would now need to be transmitted and being analyzed centrally for data analytics. Would be stored on their cloud computing's data lake with a lot of analytic platforms using those data to be able to predict or figure out problems, no, that's going to be showing up in the near future. Then for analytics, once you have all of this data, it's very advantageous, no, for any organization to be able to run various models on it, various analytics on it, and again, able to predict users' behavioral patterns, no, from buying patterns to consumption patterns. And could be as simple as, okay, we're gonna have a sale. Let's say you're a vendor of various products, and you're gonna release a sale on what's now August, September 9/9. Uh, so you could easily predict that by September 8, you need to scale up your infrastructure because you're waiting for the influx of this sale hunters, right? So you could prepare your infrastructure for that, and then maybe after a 3-day sale, no, maybe on September 10, you could start killing out all those instances that you just fired up to be able to handle the buying patterns of your customers for the sale. So that is part on a basic sense, basic analytics on how do you predict your resource. And you could even make it auto expand or auto elastic. But I've seen that also shoot organizations in the foot where they enabled auto elastic without any limit, only to wake up after the weekend, no, that they have this $60,000 bill. Apparently, one of a a threat actor, no, started scripting and harvesting their system, no, for products and trying to resell it. Unfortunately, that maxed out their instances because of the amount and the speed of the request, no, enabling the system to check that, okay, I think there's a lot of clients, so they auto expand basically their instances, uh, but not realizing that's just one client attempting to scrape their data, no, and again, when they woke up Monday morning, they have this $60,000 bill because of the amount of resource, no, that one user uh, requested on the infrastructure, and infrastructure basically auto scaled to be able to handle that. Um, Benefits also another for in favor of cloud computing is flexible pricing model. Basically, you don't have capex, no, where you have to buy all this hardware, all this space, and deploy this infrastructure. Now it's pay as you use, no. So whatever you pay, whatever you use, that's the thing you pay, no. But if you do use something that you are not aware of, like in the auto scale issue, no, you also have to pay for that. Um, I've also seen some incidents, no, that I've helped with when the threat actor was able to gain access to their cloud computing dashboard. They didn't even care of encrypting the databases and the servers. No, what the threat actor did was, okay, they got into a cloud vendor's dashboard, customer's account. No, they spawned a lot of GPU instances. Okay? And what they did was they installed CryptoCoin miners on those instances. And when we did our computation, the threat actor practically consumed, no, around $100,000 worth of resource for the company. No? And they practically made around maybe $10,000 to $20,000 in CryptoCoin mining. Now, of course, if you are an organization, you will not go into CryptoCoin mining because on that scenario, no, you're practically yielding just 20% of what you spend, no, into crypto coins, no. But for the threat actor, they're not gonna pay for the $100,000 cost, no. They already have that to $20,000 crypto mine for them, no. And it's up to the organization to negotiate for that payment, but the threat actor already have an assured $10,000 to $20,000 worth of crypto coins, no. So they won't care because if they do encrypt, there's a chance that, of course, organizations will not pay. But this one is already, they already have an assured money, basically, that they have mined on your infrastructure. Yeah. So, again, there are pros and cons for flexible pricing model, but for the most part, if you lock it down, you predict your usage, you would be able to spend and use your investment basically wisely. And as you've seen a while ago, there's a hassle-free regulatory compliance, no, where most major cloud vendors would have this system already in place for you. Anyone asks, you would be able to say that, yeah, we are compliant, and at least the vendor is compliant. Now, for your own system, you have to have your own compliance checks. Yeah, it's not necessarily uh, um, transitive that you would have those similar compliance too. So for the last part, we have trends, no, in cloud computing. With the problems we've seen a while ago, we've been seeing multi-cloud. No? While let's say AWS have their own directory service, I've seen a lot of organizations still, no, go with Azure for their directory service, and then organization would still have a lot of their workloads in AWS. So that is not necessarily hybrid where you have a public and private cloud. This is multi-public cloud. No? Again, the thing though that the organization will have to consider is they need to have expertise for the Azure one and the AWS one. So that might also be a factor, no? Because it might not be the same team, could be different team, which means your people costs would increase. No? Okay. So again, multi-cloud strategies are becoming more popular, and as you've seen with the UniSuper incident, no? GCP deleted those accounts by accident, no? But at least UniSuper have a different backup, no, from a different vendor where they were able to restore their data back. If they if UniSuper put all their eggs in one basket and suddenly that accident took place, they will not be able to operate anytime soon. No? And they might need also to close shop at some point. There's also the trend of edge computing, where it's a distributed computing paradigm where a lot of computation is trying to be pushed, no, towards the data source or the users, no, like IoT, sensors, and other connected endpoints. So, not preempt this. We'll discuss this next week, and hopefully you still attend, no, same time. A bit early, you just have your coffee in the morning, and you should be good. Okay. There's also serverless computing. No? So if you remember kanina, we have infrastructure, platform, software. I wouldn't say this is new, but this is a subset of it. No? Function as a service where you don't have any instance. You just code your function. And anytime this function gets requested in your app, it gets fired up, and then you get charged per request. No? So they are trying to basically, for lack of a better term, no, sachet these functions. No? It could mean a very good use case for expense, no? But it could also scale, no? Depends on how you use it, no? So you would need to compute, no? Should I use a dedicated server for this function, or should I use the function as a service that's offered by various cloud provider? Like for AWS, they have Lambda. For Google Cloud, it's called Functions. And for Microsoft Azure, it's called Functions. No? So apparently, AWS put some marketing term into it, like Lambda functions. But Google Cloud and Microsoft says like, okay, the hell with it. Let's just call it functions. Okay. Of course, there's also AI and machine learning, which unfortunately, no, we've seen that with the boom in crypto. Buying GPUs, even just for gaming, tends to be very expensive. No? But a lot of organizations into AI and ML started hoarding this video cards, no? That the GPUs basically that does a huge amount of computational power on its own, no? And it's also, which means it's very good for crypto coin mining. It's also very good for AI and machine learning. So the problem for us gamers right now is used to be it's just the crypto coin miner bros that's hoarding these GPUs. Now we have AI and machine learning organizations now trying to get a hold of these GPUs, no, in order for them to deploy it. Now with cloud, no, they have instances where you could subscribe to GPU attached instance, where you could now start doing your AI and machine learning loads. No? Of course, it's going to be more expensive than your typical instance because, well, you're using GPU for it. No? But in case you need, you have a use case, you have a study, you have a research, no, that needs AI and machine learning, and you cannot buy GPUs, which again are very expensive, and you don't plan on you running them maybe 24/7 for the next 3 months. Now you have just some basic use case and you want to test if it would work, then cloud would be a good starting point for you, because again, if you have the money, you could just subscribe to this GPU based instance, and you could use your those instances to run your AI and machine learning workloads. And as mentioned before, no, running crypto coin miners on this is not very cost efficient. You'll spend more than you'll earn. But a threat actor made that decision earlier that I'm not gonna use my own machine learning instance. I'm gonna use your machine learning instance. That's how they would make money. Okay, so I think that's the last one. Just have a summary here of the key learning points to be dumped to you guys.